Have you ever wondered how the universe began from nothing? But first, welcome to the Universe Unveiled channel. This query has sparked curiosity in humans for centuries. The origin of the universe, our cosmic home, is a mystery that has baffled the brightest minds. Imagine a vast expanse of nothingness suddenly bursting into a thriving cosmos. But how? How did everything originate from absolute nothing? This profound question is what we're going to tackle today. To answer that, we dive into the fascinating world of cosmology. The most accepted theory about the universe's beginning is the Big Bang theory. Imagine, if you will, a moment when there was no universe, no stars, no galaxies, just nothing. Then, in a fraction of an instant, the nothingness transformed into an infinitely small, infinitely hot, and infinitely dense point. This point, this singularity, is what we believe gave birth to our universe, according to the Big Bang theory. The idea of the Big Bang theory is not a new one. It has its roots in the early 20th century, when scientists like Georges Lemaitre and Edwin Hubble began observing that galaxies were moving away from us in all directions. This observation led to the conclusion that the universe is expanding, and if it's expanding now, that means it must have been smaller in the past. If we trace this expansion back, around 13.8 billion years, we reach a point where everything in the universe was contained in a single, infinitely dense point, the singularity. But what is a singularity? It's a concept that challenges our understanding of the universe. In the realm of physics, a singularity refers to a point where some physical quantities become infinite. In this case, we're talking about a point of infinite density and temperature. This concept is mind-bending to say the least, and it's where the laws of physics as we know them break down. Now, the Big Bang wasn't an explosion in the traditional sense. It's not as if the singularity was sitting in the vastness of space and then kaboom. No, the Big Bang was the rapid expansion of space itself. The singularity didn't explode into space. Space expanded out of the singularity. And as space expanded, the universe as we know it began to form. However, the Big Bang theory still leaves us with a question. What caused the singularity to explode? This question is one of the greatest mysteries in cosmology, and it's something we'll delve into as we continue this journey through the universe's beginning. An intriguing question that baffles scientists is, what was there before the Big Bang? This query pulls us into a realm that lies beyond our current understanding of the universe, a realm where our conventional laws of physics might not apply. It's a dizzying thought, isn't it? But let's dive into it. A popular theory suggests that before the Big Bang, there was simply nothing. No matter, no energy, not even time itself. This might seem confusing, but it's crucial to understand that time, as we perceive it, is intrinsically linked to our universe. If our universe didn't exist, neither did time. So, in a sense, asking what was there before the Big Bang might not make sense because before indicates a progression of time that might not have existed then. Another fascinating theory is the idea of a cyclic universe. This model proposes that our universe is just the latest in an infinite series of universes, each one birthed in a Big Bang and ending in a Big Crunch. This cycle repeats endlessly, like a phoenix constantly reborn from its ashes. Intriguing, isn't it? Then we have the string theory's perspective. According to this theory, our universe is just one of many in a multiverse. Before our Big Bang, another universe could have existed, and our universe was born when two branes or dimensions collided. Of course, these are all theories, hypotheses born out of human curiosity and our relentless pursuit of knowledge. Each one is tantalizing, offering a different glimpse into the secrets of our universe's birth. The truth is, we may never know what was before the Big Bang, but that doesn't stop us from exploring the possibilities. So, how could the universe originate from nothing? It's a question that has puzzled thinkers and scientists for centuries. The answer might lie in the fascinating world of quantum mechanics. In this realm, we encounter the concept of quantum fluctuations. These are temporary changes in the amount of energy in a point in space, as predicted by the Heisenberg uncertainty principle. This principle states that the more precisely the position of a particle is determined, the less precisely its momentum can be known, and vice versa. Now let's dive a little deeper. Imagine a perfectly empty space, a vacuum. According to classical physics, this space should remain empty. But quantum mechanics tells a different story. It suggests that this empty space is actually seething with activity. In a quantum vacuum, particles and their corresponding antiparticles can spontaneously appear and annihilate each other. These particle-antiparticle pairs are known as virtual particles. They borrow energy from the vacuum for their brief existence and then return it when they annihilate. ensuring that the overall energy remains zero. Here's where things get really interesting. Some cosmologists speculate that our universe might have originated from such a quantum fluctuation. A tiny particle-antiparticle pair, springing into existence, might have provided the spark for the Big Bang, setting off a chain reaction that led to the formation of our universe. In the quantum world, nothing is truly nothing. Even in a perfect vacuum, particles and antiparticles are constantly popping into and out of existence. The origin of the universe is a complex topic full of mysteries and unanswered questions. Let's recap what we've explored. The universe as we know it started with the Big Bang, an enormous explosion that marked the beginning of time and space. This cataclysmic event created the fundamental particles and forces that make up our universe today. But what came before the Big Bang? Theories suggest a state of nothingness, which wasn't actually empty but a sea of quantum fluctuations. These fluctuations, according to quantum mechanics, could give rise to tiny bubbles of space and time. One of these bubbles could have ballooned into our universe, starting the Big Bang and the expansion that continues to this day. While we may not have all the answers, the exploration of these questions helps us understand our place in the cosmos and keeps pushing the boundaries of our knowledge.